This is a video key for Unit 2 Test Study Guide. Learning Goal 1. I can explain whether a relation is a function. Question number 1. A graph represents a function if it passes the vertical line test. When we're talking about a vertical line test, we use that when we're talking with relation to the function. A table represents a function if the x values do not repeat. Remember, one x value goes to one y value is the idea of a function. On question number 3, a relation is a function if every input has exactly one output. All of these things basically saying the same thing, just the different multiple representations that we had. Question number 4, determine if the relation is a function, explain why or why not. 4 is not a function. We can see that the x value of -4 goes to two different y values. So much like what we said in number 2, a table represents a function if the x values do not repeat. Same thing for a set of ordered pairs, represents a function if the x values do not repeat. Here we have the x values repeating. So our reason is the x values repeat, or one x value goes to multiple y values. Question number 5, we see that we have a mapping diagram, and this mapping diagram is a function. And the reason being is that each x value or input goes to exactly one y value or output, but much like question number 3 above. Question number 6 and 7 determine whether the inverse of the relation is a function, explaining why or why not. So what we have given here is we are given a graph of the function for number 6 and for number 7. So we can't actually see the inverse. What I would have to do is I would have to graph it in order to determine whether it's a function. Or we could use our shortcut, which is the horizontal line test, which tells us whether the inverse of a graphed function is a function. In number 6, we see that it passes the horizontal line test. And in number 7, we see that it fails the horizontal line test. So number 6, the inverse is a function. And for number 7, the inverse is not a function because it fails the horizontal line test. Learning goal number 2, identify inverses of a function. Question number 8, the inverse of a function has an inverse if it passes the horizontal line test. A function and its inverse will be reflected over the line y is equal to x. That is the dotted line going across the diagonal. Y is equal to x. Question number 10. Using that idea then, we should be able to sketch the inverse of a function using 3 points. It's going to be a reflection across the line y is equal to x. In order to sketch the inverse, what we first have to do is find and label 3 points on the function. So what I've done is I've labeled these 3 points, 0, 0, 1, 1, 4, 2. And on this function, I've labeled -3, 5, -1, 3, and 0, 4. The way we actually graph the inverse is we switch the x and y coordinates into the yx for the inverse, meaning that on number 10, we're going to graph the point 0, 0, 1, 1. Now, these happen to fall right on top of the original function. But then we have 2, 4. And if I follow the same pattern of the graphs, we get the inverse of our function. For number 11, when we switch the xy coordinates into yx, we get from -3, 5 goes to 5, -3. -1, 3 becomes 3, -1. And 0, 4 becomes 4, 0. Now, I don't have enough room to graph that on here, but hopefully we'll be able to graph these x and y coordinates, and we'll be able to come up with the inverse of our function. Learning goal 3, identifying extrema, zeros, intercepts, and x values. The relative minimum can be smaller than the absolute minimum. This is, in fact, a false statement. Why is that? The absolute minimum means it is the smallest value on the graph. Smallest number. Relative is just a minimum that occurs locally on the graph, but the absolute is the absolute smallest. A 0 is another word for x-intercepts. The other 2 words we use are solutions and roots. Zeros, solutions, roots, x-intercepts, they all mean the same thing. We're looking for where y is equal to 0. Question number 14. What does y equals 10 look like? This is, in fact, a horizontal line. Remember, x points are labeled as xy coordinates. Horizontal lines are of the form y equals some number. Question number 15. A function of x appears to have 2 distinct real solutions. Circle the best answer. Remember, another word for solution is, we just talked about root, x-intercept, and zeros. So here what we're doing is we're looking for a graph that has 2 x-intercepts Looking here, we see that this graph has two x-intercepts. The first one doesn't have any. Second one doesn't have any. Notice there's no x-intercepts there, no x-intercepts here. Here it looks like we hit 1, 2, 3 times. So 3 solutions. Here we're looking for just 2. Okay, question number 16. We need to use ordered pairs to represent all of these points if they are there. So we'll start with x and y intercepts. X-intercepts from the graph are -3, 0, and 0, 0. Y-intercept is also going to be 0, 0, where the graph crosses the y-axis. Now, absolute min and absolute max, if we look at our graph, the graph goes up forever and down forever, so there is no absolute min and no absolute max. However, we do see a local min or relative min and relative max on our graph. Those are a peak or a valley in our graph. We see that the relative max occurs at -3, 0, and our relative min occurs at this point, which is -1, -4. -3, 0, -1, -4 for our answers. Question number 17, 18, and 19 are asking us all similar ideas. So let's take a look at number 17. What are the zeros of the function? Zeros meaning x-intercepts, so those occur at -5, 0, -3, 0, 2, 0, and 5, 0. Now, relative mins and relative max, these occur at peaks and valleys in our graph. So relative max, we have a -5.5, 5.5, and relative mins are going to be these two valleys down here, -4, -2, and 3.8, -4.5. Now, absolute mins and absolute maxes, since this graph goes up forever in both directions, there is no absolute maximum. However, there is an absolute low point on the graph, and that occurs at 3.8, -4.5. So this is a relative min locally, and it is in fact the absolute min as well. Turning points, number of peaks and valleys we have, so we see that there are 3 turning points. Question number 18, using the graph, identify same ideas. Let's look at x and y intercepts. X-intercepts, there are none, but there is a y-intercept at 0, 7. Absolute min, absolute max. Let's start with relative min and relative max. There is a relative minimum at 4, 3. It is a valley in the graph, but there is no relative max because the graph continues to go up forever and ever. There is no peaks in our graph. So since the graph continues to go up and up forever, there is no absolute maximum, but there is an absolute minimum, again, at 4, 3, which was a relative min as well. Question number 19, last of this group. We're looking for x and y intercepts. X-intercept at 0, 0, 1, 0, and 6, 0, and a y-intercept at 0, 0. Now we can count the number of turning points. We see that there are 2 peaks and valleys together. So let's figure out what the relative mins and maxes are. We see you have a relative max at 1/2, 1/2, and a relative minimum at 5, -10. Now, once again, this graph goes up and down forever, so there is no absolute minimum and no absolute maximum. So we just have local or relative max and mins, peaks and valleys in this particular portion of the graph.